Welcome everybody to another MBW champion playing puzzles, playing Sudoku. Ho ho ho. Today we are going to be playing Lumos Maxima. I wasn't going to film one today, and then I was just kind of browsing around YouTube, and I saw that Simon from Cracking the Cryptic was doing like a fog puzzle. I saw the thumbnail and I was like, is that like fog? And then sure enough, I look and it basically says right here, the grid is covered in fog, and basically there's two initial lights, so it gives the parameter of what rule sets are here. But you don't know what the rest of the rules are. So basically, say for example, I don't know how this cage ends. But if I put a digit, let's just say I put a digit right here, it will reveal everything around that one, and so then I'll know what next rule sets are right here. That's freaking amazing. It reminds me of Advanced Wars, and so immediately I was like, I want to do this puzzle and I want to do it on my YouTube. So I got it, and then I finished work. So I just finished work right now. Actually, I had to run out the door, but now I'm back. And so now that I'm here, I want to do the puzzle. So let's freaking do this. This may take a long while, so I'm just going to start it right now, so that we can do it. So doesn't look like there's a timer on this thing. Well, let me read the rules to you anyways. So standard Sudoku rules apply. So again, if there is a digit right here, for example, that means 1 through 9 is going to be in a row, it's going to be in a column, and it's going to be in a cell. You guys know standard Sudoku. Come on. Digits along arrows sum to the number in a circle. There are only one cell circles in this puzzle. So digits can repeat along arrows if allowed by other rules. So this cell right here is the sum of this entire thing, but it can repeat as long as it goes to another box or it's another row. So given the other Sudoku rules, it has to follow that. But there can't be 2-digit ones, so it's all going to be single digits, 1 through 9. So cages don't intersect with other cages, so these sum cages don't intersect with each other. Oh, I skipped one. I skipped this, sorry about that. Cells in cages must sum to the given total, or the given in the corner of the cage, and digits cannot repeat within a cage. So digits can't repeat in a cage. And say for example this one has to add up to 8, because that's the number right here, and then whatever this is, basically this is gonna add up to 23. Alright, can't intersect. Grid is fog. Put the correct digit in. So you have 5 lives. That's why there's 5 hearts right here, Legend of Zelda style. You have 5 lives to solve the puzzle. If it takes 1 life to enter a wrong digit. So if I accidentally put a digit in right here, then it's going to take a life in if it's wrong. No guessing is required to finish the puzzle, and I'm going to try, I don't want to guess at all. That's not how I like to do puzzles at all. So I have to make sure I try not to accidentally put in a full digit, because that's the worst thing I could do, is basically be showing you something, or trying to pencil mark something and then accidentally put in a digit and it goes oh, you lost a life. So I have to be very, very careful and conscious not to be doing that. But yeah, no guessing is required. Extra lives are only given to allow room for possible typos. Yeah, so again, I could have a typo. Hopefully I don't, because then it would reveal what's behind the fog, I'm guessing. So that would kind of ruin the puzzle. But even if we do that, I'll try to stick to the logic and try to make sure I don't know this, and then we'll just continue. So anyways, let's get started. So where do I want to start? I'm gonna start here first, just because it's on the upper left. I'm gonna pencil mark what digits can be in an 8 cell. So 3 digits have to add up to 8. So you have a 1. Oops, sorry. A 1, 2, 5. A 1, 3, 4. And actually, you can't do 6, because it would have to be 6, 1, 1, and you can't repeat a digit in the cell or a cage. So these are the possible digits that are right here. I did notice while I was going through that, though, that it is required to have a 1 in here, because if you didn't have a 1, the lowest minimum that you could do is a 2, 3, 4 pair, which is a 9, and that's way more than an 8. So 1, 2, 3, 4, 5. The 23 over here, if you look at the edge of here, if this cell and this cell was included in here, it would have, the dotted line would have went this way, but it actually curves in this way. So we at least know that it comes out this way. Maybe we should make a color. So we know that this is part of the cage. We don't know if it extends further. We know that it doesn't come here, but it could extend further depending on here. Actually, we have another 8 cell here. And it's a 3, so it's the same rules as this. So basically it's going to be a 1, 2, 3, 4, 5, because it's the same rule set, and it also requires a 1 in it. But look at that. So but since we know that a 1 is in this cell, that means because this is in the same cell as this, that means this doesn't have a 1 in it. So no 1s. So in fact, this is our 1. Let's make sure we're highlighting it correctly. And then since this sees this, this is the 1. Alright, let's take off our thing so we don't accidentally mess anything up. Alright, and 1, 1, so there's going to be a 1 somewhere down here. And what's cool about this is we have 4 digits that are seeing each other, so like 2, 3, 4, 5. So we know that none of these squares right here is a 2, 3, 4, 5. So in fact, these are going to be a 6, 7, 8, 9. We don't know where, but that's the case. Now, so I don't want to look at, I'm not going to do this yet, but let's look at the 23. So the 23, so let's just do the minimum. So the minimum 6, 7, 8. So that's 15 plus 6 is 15 plus 6 is 21. So that would make this a 1 or a 2. If it was a 9. Wait, did I do that right? The 21, and to get to 23, it would be a 2. But if it was a 6, 7, 9, then it would be a 1. So this is going to be a 1, 2. So again, let me say that again. So if this is a 6, this is 7, that's 13. And then plus 8 is 21. So that would be these 3 digits. And to get to 23, you can't have a 1 plus 1 because then it would be in the same cell. So it has to be a 2. So a 2 would go right here. But if it was a 6, 7, 9 pair, then this adds up to 22, and so this would have to be 1. So this is going to be a 1 or a 2. And one thing I noticed from here is that there has to be a 6 in here, because like 7 plus 8 is 15, plus 9 is 24, and that goes over. So like these 3 digits go over 23 already. So this is required to have a 6 in it. I think there's supposed to be a 7 too, like, so, because like now that I'm thinking about it, 6 plus 8 is 14, plus 9 is 23, so these 3 digits is 23 already, but we know that this cell extends to here, so 23, the only way to like keep it there is to have this 0, and you can't do that. So this also requires a 7. We just don't know if there's an 8 or 9 here. But this at least gets rid of the 6, 7 possibility from here. So this is an 8 or a 9. Okay. Let's move on over here, I guess. So again, this digit is going to be a sum of these digits. Since this isn't a row, I'm just going to put the lowest possibilities that it can be. It's going to be a 1, 2, 3. I'll see if it gets any higher than that, but a 1, 2, 3. So that's already 6. And it extends to here, so we at least know that there's still some right here. So let's still keep it low. So this is like the lowest that this can be. So this is 6, 9. Oh, that's exactly okay. So yeah, the minimum that this can be is a 9. So that is automatically a 9. All right, that was cool. Sweet. I was a little scared for some reason. I get a little scared because I'm like, like when you're putting a digit, I don't want to get lose a life. So I'm like, is it? All right. So since there's a 1, 2 pair here, that means there can't be a 1 or a 2 right here. So this is a 3. Yes, sir. 3 gets removed from here, and we see more here. So this is like a single digit, but it extends here, but we don't know if it extends further than that. We at least know that if at minimum, if it's a 1, 2, 3, well obviously 3's right here, but 3, 2, 1, that this is a 6, 7, 8, or a 9. It's at least the minimum that can be. Okay. Oh, check this out. That's cool. So since we know that the 1 has to be in this column, this 1, 2 pair basically covers the 1 here. So we know that this is not a 1. And this 1, 2 pair also sees this one, so that's not a 1. So we actually have this digit, 1 right there. Ooh, what shows that? That's interesting. No real clues though. We do know that there's going to be a 2 down here because of that same logic. 2's seeing this row, 2's seeing this row, and then we have the 2 right here. But in fact, we have 2's right here. So there's no 2 right here. There's no 2 right here. So the 2 is going to have to go somewhere right here. Nice. This digit. If this can't be a 1, can't be a 2. Could go. How do you do this one? Because I'm trying to assume. I know at least it goes up here. It could go back. Could go up like that. Could go this way. We don't know. We know this goes this. We know this is fed to here. Wow. Oh, check this out. So, if this was to extend, let's just say it extends here. So, this plus this equals this digit. This is being seen by 1, 2, and 3. So this would have to be... This would have to be a 4 or 5. 6, 7, 8. That's cool. Okay. Reason being... is because if you add... Oof, this is rough to kind of see. It's either going to be this. Like, it's either going to be like it only extends to this digit, so this digit is going to repeat here, which would be a 4, 5, 6, 7, or 8. It can't be 9 because then the 9 would see this, which it would have that. In this scenario, if it was a 1 digit. But if it was a 2 digit, we also can't let it equal 9. And if it's a 2 digit, you can't have 9 plus something be lower than a 9. So obviously there's no 9 in here. In fact, there's no 8 in here either, because I just thought of that. Oh, no, never mind. There could be an 8 because it could just be this. Like if this is an 8th and that's an 8. So there we go. So that these are the digits that could be right here. And if that's a minimum, then I'm just gonna pencil mark this in. If that's a minimum, then this is equal to that. Because we know that, this 3 has to be somewhere right here. And since we know the 3 is automatically in these, it's going to be in here, these 2 rows are covered because the 3's are right here. So that means there is a 3 in this column. Okay. What does that do? I have no idea. I don't know if I'm going the right way, but okay, same right here. Let me see. Let's just assume that this is a a 6. It can be a 1, 2, 3. Of course, we know that there can't be a 3 here. We can have a 4 to get to 7, so 4, 2, 1. We can have a 1, 3, 4 pair to get to 8. Can also have a 5. 5. Damn. So it can really be, it could be a lot of things. It could be a 6 as well, because like 6, 1, 2 would be a 9. And I can't lock anything in like a 1 or anything because it's... Because a 2, 3, 4 pair... I mean a 2, 3, 4 triple would make a 9, so that makes it where it doesn't need to be a 1. And we don't have to have a 2 in there because it could be like a 1, 3, 4 to get an 8, for example. That's not it. There's no way to figure out that. Oh. I just noticed something about these bookmarks. Yes. Yes. Oh. Oh. Check this out. That's cool. Okay, so we don't know which one is the sum and which one is the arrow, right? And it could even go longer than that, but we don't know. But we do see that this is at least part of the sum. But there is a 1, 2, 3 here. So none of these digits can be this. So let's just say it's a 4. So 4 plus whatever's here is equal to this. Well, there's not a 1 or 2 or 3. So the lowest this can be is a 5, which would make it a 9. Same thing as 5. If this was a 5, then the lowest that this can be is a 4. So in fact, this is... I don't know if that made sense. So basically, like, because the 1 and the 2 and the 3 are here, there has to be, like, it has to be a 4-5 pair, because if it goes any higher, if it's like 4-6, it's 10. And again, we have to have 1-digit sums. So it has to equal 9. So that means one of these two is 9 down here. And we know that that whatever here, it's going to be a 4-5 pair. That is awesome. Wow. That was like super cool. I like this fog. Can we make more of these puzzles? That was cool. This 9 is seeing this. So since that's the case, there cannot be a 6 here. 9. I don't know if that did anything. I don't think it did. But that was super cool. Okay. What does this tell us? So there's a 4 and a 5. So the 4 and the 5 have to be in one of these two columns. And we know that the 4 and the 5 have to be in these two columns. So that means we know that the 4 and the 5 have to go here. So this is a 4-5 pair right here, which we know based on here. And if it's 4 and a 5, it's not going to exceed that because it can't be 1, 2, or 3. So this is also a 4-5 pair right here. 4-5 pair on a row and a 4-5 pair on a column. Holy cow, man. Wow. I'm really happy about this puzzle, by the way. This is like making my, like, this is making me smile so much. You don't even know. Where do I go from there, though? So we have a 1, we have a 2, 3, 4, 5, 6, 7. Oh! Oh my god! Check this out. So I was literally just gonna say, and I'll write it out this way just so you can see it. So this has to be a 2 or 3, right? I was just gonna say that this can either be an 8 or a 9, because the 6 and the 7 have to be right here. But this can't be a 9 because we said that this has to be a 9. Like, because of this sum right here, these two have to be 9. So this is not a 9. It's an 8. And if that's the case, just getting rid of some pencil marking. If this is an 8, that means there is no 8 right here. So this is a 6, 7, 9 pair. Just get rid of some bookmarks, which makes this an 8. I'm still scared when I press the thing. Which makes that an 8. Let's get off of that. So there's an 8 down here somewhere. 8. And that makes that a 6, 7 pair. And since we know this is a sum of this, that means this is not an 8. Could be a 2 or a 3 though. Okay. Let's stop right there. 6, 7, 13, 9. So this is a 1. Let me do that again. 1 plus 9 is 10, plus 13 is 23. So this has to be a 1. Oh. Oh my god, I'm so happy. We revealed some more fog. There's like a gnat flying around. Okay. 45. Okay. So, in Sudoku, there's digits 1 through 9, right? The sum of 1 through 9, if you add all of them together, is 45. Since a cage cannot repeat any digits, and this is a 45, that means this cage actually has every single digit 1 through 9 in this cage. Now what does that mean? Well, at least we see the dotted line, so we know that this doesn't have it. Let me highlight it. So we know, because the dotted line's coming out to here, that this is part of the cage. We know that this is not part of the cage because it indents. It would have went down if it was part of the cage. So we know this is not. So how much is this? 1, 2, 3, 4, 5, 6. So we have 3 cages left. Can't be here. So can't be here, can't be here. Let me highlight that. Can't be here, can't be here. So it could go 1, 2, 3. Can't go here because we see that and we don't see the cage. It could go 1, 2, 3, 4. Yeah, because this is 5, so it's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So at least can be any of these digits. I'm just like highlighting whatever. I just want to see how far it can extend. So let me see that if I did that again, right? So 5, and then it would just be a thing of 4s. So like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Oh wait, it can go this way. Damn it. 1, 2, 3, 4. No, we know that. We know that's a digit. Okay. 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 So that should solve it. What the hell does that mean? So we know that every digit has to be in there. So 3 sees this, so that means there is a 3 here. Let's bookmark that. So the 3 is in here, so we know if it went like this, for example, the 3 would have to be outside the cage because it was already used once in a cage. Kind of keep that in mind. Same thing as the 1. The 1 cannot be in here because there's a 1 in the cell, so it has to be in one of these. In fact, okay, so the 1 is seeing this. This 1 is seeing this. There is no 1 here. So the 1 has to be somewhere right here. So for example, this can't be a solution. So let's get rid of this. And the reason why is because if it went this way, then there can't be a 1 anywhere because there's already 1 seeing that entire thing. So the 1 is in one of these 4 places. Oh, we got rid of the 9. It's the same logic as this. We got rid of the 9, so the highest it can be is an 8. So it has to be a 1, 2, 5 or a 1, 2, 7. Oh wait, sorry. 1, 2, 5 is 8. 1, 2, 4 is 7. Oh no, there's a 3 in there. Never mind. Oh wait, that still checks out. 1, 3, 2, 6. I'm trying to see if I could do it without a 1, but no, yeah, it would be a 2, 3, 4, which would be a 9. So yeah, there has to be a 1 somewhere in here, which makes this not a 1. So now the 1 is in either of those places right there. It's interesting. Because then that can still be a 1. There's nothing stopping this from being 1s at all. Four, 5? 4, 5? No, because it could still be a 3. let's see this. Just trying to think. This has to go. Oh no, it can go this way. That would be 5. Oh, but no, there's a 1 right here. So the 1's seeing this column. So if this went like this, for example, or like this, whichever way, minimum that could be, because it couldn't be an 8 right here, would be 2, 3. So this would be a 5. So this would have to be a 1 or a 2. So there could be a 2 right here. But it could also go this way, which would be a 4 or 5. Or 3. What am I missing? Just trying to imagine if this is the 1, go right here. Oh. Check this out. I don't know if this is the solution, but I mean, I think it is. Let's just say that this is a 6. If this is a 6, and we're saying it's part of this, because it has to be a 9-digit thing, so 1, 2, 3, 4. Like, let's just imagine that's here, right? If this is a 6, this 6 is blocking this, so a 6 would have to be in here, but it can't repeat. So whatever digit you have in here, again, 7, that means a 7 would be right here, but there can't be a repeating 7, so like this is impossible. So this one can never be. This one can never be a digit. I mean, in this cell, because it always blocks it because of this. Because then it would be inside it. So that is not a cell. So in fact, that makes that a cell. 1, 2. So it could go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we at least know that it is here. 1, 2, 3, 4. Yeah. Okay. So we know that the 1s have to be either right here. 1, 2, 3, 4. This one didn't really help too much. We just at least know it didn't reach here. This is... If that's a 2, that'd make that a 1. 2 would go right here. Still check, that checks out. Oh, you know what it can't do? It can't all be in here because whatever that digit here, again, oh no, never mind, because then it would go right here. Oh, never mind. Oh, but same logic here. So whatever goes here in this digit, no, it's this one. Is it? I'm trying to think if this works the same way. So, if this is... Oh, wait a minute. Wait a minute. Oh, okay. So, look at the 1. So again, there has to be a 1 in this cage, right? So, if I was to extend it this way, there can't be a 1 right here because there's a 1 seeing all those digits, and again, the 1s have to be right here. So this is not a solution, and this is also not a solution. It's 1, 2, 3, 4. And there's no 1 in it, so it has to go 1, 2, 3, 4 or 1, 2, 3, 4. Okay, we're dwindling down this cage. It's getting close. If the 1 is right here, yeah, look at this. So let's just say I have the 1 right here. That means this has to be a 2, 4, or 5, right? But it has to extend here. So this makes this digit part of the cage. So let's just pretend this is the whole cage. So if this is a 1, that makes this a 2, 2 or 4 or 5. But same logic that we had on this one. If we had a 2 here, that means it's not going to be anywhere here, but then it would also have to be on this cage right here, and it can't because it can't repeat. So any digit that's that's not a 1 is going to repeat because this 1 is outside of the cage. So if we had the 1 here, it's seeing this, but of course there's a 1 right here, so there's no 1 repeating. So this is a 1. And I'm afraid to press it. Oh my god, so beautiful. I am so happy with myself. Actually, let me how do I there we go. Oh, it tells us the cage. Okay. I just noticed that this thing is showing the whole cage. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we know the cage now. Cool. So get rid of this, the 1 bookmarks. So again, this is a 1, 2, 4. Yeah, still can be any of those digits. Well, that was fun. It was fun, right? So we know a 3 is going to go somewhere right here. Because this 3 is seeing this, and this cage reserves these ones, so the 3 is somewhere right here. Oh, the 1 is seeing this. 2, 1. We were correct here. Cool. So this 2 is seeing this. It's a 4, 5. Oh, this is a 4, 5, 9 pair right here. So that means this can no longer be a 4, 5. So it's either going to be a 2 or a 3. 1, 2, or 1, 2, 4. 1, 2, 4. So it can no longer be a 6. Because the lowest that this can be is a 1, 2, 4 pair, which is a 7. So this is going to be a 7 or an 8. Since this 2 is seeing this, that means the 2's up here. So that means it can't be part of this cage. 2 is seeing this, so 2 has to be somewhere right here. Whatever the 4 and the 5 is going to be, let's just say this is a 4. It would be in this cage. So it would either be right here, which would make... God, this is complicated. So in other words, this is going to be a 2, 4... Like it could never be a 6, for example. Like it has to be one of those digits. Oh, wait. I said that wrong. Hold on. I said that wrong. If this is a 4, that means a 4 would have to go here. But then also could go here. Okay, never mind, never mind. I don't know what the hell I'm talking about. I was dead wrong with that. I mean, could that logic still make sense, though? Like... 4, 1... Just not sure over here. Where's the 9 go? Could go right here or right here. Oh wait, no, the 9's right here. Never mind. What else digits? It's not really saying. Could be a couple different ones. I don't think that's it. What am I looking for then? Maybe this arrow. This arrow just showed up, so let's look at that for a second. The minimum that this could be is a 4, 5, 6. I'm just gonna put these digits in really quick. Because let's just say this is 9. This could be like 8 plus 1. Oh, actually no. 1 is seeing it. Oh, and we know the 1s are down here. So this is not 8. Can we do that same thing here? This is a 7, 1. That's really not telling us. Either way, we know that this is this, right? So this could be a 2, 3, 4. Because 4 plus 5 would be 9. So this could be a 7, I mean a 6, 7, 8, 9 down here. I don't know if that really told us anything. Maybe now that we have digits, can we solve this? Like, again, this would be a 5, 2, which make that a 3. Again, 2, 3. No, sorry. Can't be a 3, 2, 3. It would have to be a 3, 2, 3. 3, 2, 3. Oh, you know what? This can never be a 2. Because if this is a 2, 3 pair, like let's just say it went this way, like bam, like that, it would be 3, 2. Oh, it could be a 3, 2, 2. 3, 2, 2. Which would make these all 2s. The 2 would have to be here. Hmm. I just noticed that this top digit, it always has to be on the upper left. This doesn't have a digit on the top, so that means it does extend up. So let's just say it's here. God, that's bright red. It could extend up here, but it can't go this way. So it'd have to go like up here, whatever. But we know that the 1 is down here. already, if we had 2, 3. Just trying to think. If we had a 2, 3 pair, the minimum that this can be is a 5. This could be a 1. I'm just pretending really quick. Oh, we don't know. Never mind. I was treating this like it was a single digit. We don't know if it can be like a 23 again. Never mind. Never mind. Get rid of all that nonsense. What we do know though is at least it does extend up. So I'll just keep that there. It does extend up and it does include a 1 because, oh no, never mind. There could be a chance that it can't be a 1. Never mind. Okay. Oh, this could still, oh, never mind. 5, 2, 1. It's an 8. Wait. Yeah, never mind. I just can't have like a 5, 3, and a 1. So this is a 5, 3. 3 would go right here. I don't know if that did anything, but maybe there's some sort of like X-wing thing here. Let's just pretend it goes out to this. Let's just pretend. What are the digits that this could be? It could be a 4. Can't be a 3. I mean, it could go this way, and then it could be a 3. Ugh. I at least know that this... Maybe let's just do that. So... we know that there can't be a 2 here, so there could be a 2 here. There could be a 3. And again, that's if this is 2, 3, 3. I mean, like that. Right? Wait, this can't be a 3. Because I do know that this goes this way. This isn't a 3. Can it ever be a 3? I guess if it goes down here, like Like, so 5, 2. No, that would make that the 3. So yeah, this can never be a 3. What the hell? And since there can't be a 3 here, and this can't be a 3, I was just gonna treat this as a 2-3 pair, but there could be a 2 here. Never mind. Damn. Okay, let's keep going. So can't be a 3 here. 4 though. So like 2 plus 4. So this could be a 4. This could be a 4. Oh, what if it extends up here? Oh no, we can see that. Never mind. It's not behind the fog. So 2, 4, 3, 4, 3, 4, 3, 4. Could be a 4 right here. What about a 5? Could be a 5. Oh, look at that. Because it can't be a 6, because then it would be anywhere here, blah, blah, blah. This is if it touches it, though. I was gonna treat this like a pair, like right here, but this is if it touches it. I don't know if it touches it yet. Because it could go right here, and then this can be whatever it damn well pleases. Yeah, because if this is, so whatever is here, like 4 or 5, it's going to be right here. I just know if it does go like this, it can't. It can only go like that. I'm kind of sad that I got. I'm just so stuck. Like I don't want to guess or anything, so like it's frustrating. Because 9 can go anywhere right here. Because 9 is right here. It can't be on this thing. 9. If a 9 is right here, or it has to be right here, I mean a 9 has to go right here somewhere. So we know that there's a 9 here. There could be a 9 here. It's still not helping. I thought that was going to help a little bit. 9 has to go somewhere right here. Really, 9 can go anywhere right here, except right there. I don't know why I'm bookmarking that. I'm just trying to figure it out. This is a 6. The 6 would have to go down here. I was trying to catch it up here, but I feel like it's something with this still. So if the 5 is right here, that means it can't be part of this. This could be a 4, could go down there. Wait, can this be a 3? I totally remember that I was like trying to come up with something. So like if this is a 2, that's a 3. 2, 3. 2, 2, 3. That's the only way that this can work. 2, 2, 3. Yeah. So if I wanted this to be a 3, but I guess this could be like a 2, 4, and then 6, and then this could be a 3. Damn. Never mind. I'm gonna get rid of these before I confuse myself. I at least know that the 3s are here. 3, 2s are right there. 1. Do I need it? Do I know anything else about the 1s? No. What about here? So 1, 2's gonna have to go somewhere right here. 3, 4. Alright, let's just pretend this is 4. 4, 2, 1, right? So that makes that a 7. This 5 plus 2, make that there. 6 plus 2, 7 plus 2. I am not seeing what I'm supposed to be seeing. I'm kind of sad that, like, I was going, I was moving, and then all of a sudden, just, it stopped. And I know, like, once I get this final whatever clue, whatever, it's gonna flow. But unfortunately, we are not there. So we know the 2 and the 3 are here, which makes that here. What about this? Since we know that there's no eight or a 9 here, that means the 8 or a 9 have to go here. If the 9 was right here, let's just pretend the 9's right here. That means that the 9 would have to go in here, but this is seeing it, so this is not a 9. Can we do that with 8 as well? I don't think so. Like if this was 8, these two can still be 8, and then that can be 8. So that doesn't work. And again, whatever digit's right here is going to be in here. This is a 7. Or 6, it would see that, which would make that a 7. It's not really doing anything. Man, I really wish we knew what was going on here. Could go down. That's the problem with it, is like it could go down. It could go 2, 3, 2, 2, 3. Wait. Why do I have this as a 2 again? 2, 3, 2. No, it can't be 2, 3, 2. 3, 2, 2. That's what it was. 3, 2, 2. I feel like I want to like so let's just pretend Let's just pretend this is a... I don't know how I'm going to bookmark this. Let's just pretend it's a 2, 3, 2 down here. Because it can't be a 3, right? It can't be 2, 3, 3, because then, yeah, that would go over. So it would be 2, 3, 2, 2. Okay. So in this scenario, I can't have a 3, 3. I can have a 4 though. Okay. Anyways. Two, 3, 2 is 7. This would make this a 3. Three would go over here. It's just not... This would make that 7 also. 7. I don't know why that matters. Folks, I am not seeing the clue at all. This is not good. I think either way, if this was like a 3, this could still be a 2, huh? 2, 3. I'm really sad. Because I think I'm gonna have to wave the white flag on this one. I am not seeing. Nothing like over here, right? Like. Because this would be 3 and a 5. Oh, sorry. I forgot the 1 is right there. A 3 and a 4 and a 1, and a 2 and a 5 and a 1. This was the 2, for example. And the 2 would be here. The 5 would also get rid of that. The 5 would have to be here. Which would make the 4 automatically right here. So the 4 would have to be here. I think that logic is going to do it on both sides too. Because let's just say this was the 4 and the 3. 4 and this 3 sees this, so the 4 is removed from here. This would be the 4. No, never mind. It could go right there, that way too. Frustration. Would make the 3 here. If this is the 3, make the 3 here. It doesn't matter because it's right there. Whatever digit's right here, so let's just say it's a 7. If it's a 7, it has to go somewhere right here. It sees that. What if it's an 8? If it's an 8, that means it have to go right here somewhere. It's in there, be there. Again, we know this goes up. let's just say that we don't know this is a 1. I mean, let's just say it's not a 1. If this goes any further than this, it would have to be a 2, 3, a 2, 3, 4, which would be a 9, so it wouldn't be able to go up. So we do know that this goes up. Now, if we didn't say that this is a 1, and this could be a 2, 3, 4. Oh, I forgot. We don't need to say that this is a 9 cell because it's a freaking cage. If this is a 3, can we do 2, 2 like that? 3, 2, 2. No, we can't. This is a 3, and this is a 2. That would make this the 3. I just messed myself up. I got excited for nothing. 2, 3, 3. I mean, sorry. 2, 3, 2, 2. I meant to say 3, 2, 2. 3, 2, 2, 3. Basically, make the 3 right there, the 2 right there. God, I want to put in some like numbers to visualize it, but like I can't because then it would like tell me if I'm wrong or like it would take away lives. These 3 digits match these 3 digits. Those 5 match these. I am freaking lost. Oh, wait a minute. So let's just say this is a 4-5 pair right here. If this is a 4-5 pair, that means this would be the 9. Four, 5 pair. This will be a 4-5, and then one of these will be a 4-5. Never mind. Dang it. We know it has to come in here at least once. And if it does, it can't be a 3. 1, 2, 3, 2. 2, 3, 3 would be over 8. So it's either going to go like this, a 4 or 5, or it's going to be a 2. So it's going to be one of those digits, right? Somewhere here. That's what it's going to be. Let's just say it's a 5. Let's make a 4, 4, 5. 5. Oh wait, we said that this is not a 9. This is a 9. This 9 is seeing this, and then we said that these are not 9s, right? Oh, never mind. Dang it, the 9 is right there. Ugh. I think I did that earlier. My God. I think that the this is a 2. That makes that a 3. It would have to go out to here. So it would be a 3, 4. That's if this was a 2. Making this not possible to have a 6. Could be a 5-2 still. But if this was a 5 and that was the 4, then this wouldn't work. Yeah, so if this is a 2, that would be a 3. So this can't be a 2. If this is a 3, this would have to be a 2. Which would make this the 4 or the 5. So this would have to be a 9. But let's just say if we go 2, 3, 2, 2, 3, 2, 3. That means this would have to be the this would have to be the 4. This can be anything. 7 not though. So 3, 4. This could still be a 7. 3, 4. So that was a 5. Oh no, wait. It's 2, 3, 2, 3. So it'd have to be 3 plus 4. So this would have to be a 5. So 3 plus 5. So it can't be a 7. This can't be a 4 anymore. It can't be a 7 anymore either. But it can be a 5 or a 6. One, two, three. Six. So weird. Wait. This being a 3, 4, 1. Again, if this is a 2, 3, 2. 2, 3, 2. This would have to be a 3, 4, and so this would have to be an 8 actually. And if this was an 8, that means the 8 would have to go right here as well because we just pulled in those, but that can't be true, so this is not true. So the diagonal's not going to ever go that way. It could go this way. But if it does, then this is the 2, 3, so this would be 4, 5, 9, so this would be a 9. This would be a 4. This would have to be a 2. So this has to be 8. In both scenarios, it's 8. That's an 8. No! No, 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 no. Dang it, see, this is why I want to put digits down. See, now I know, but now I know it's a 7, but damn it! Why wasn't that logic solid? Why wasn't it solid? Because I could have a 2... Because I could have a 2, 4. And then this can be a 3. Oh, that's why. But if that's the case, it's not gonna go there. Four, 4. Five and 2. 527 63. I feel like the only way that this can work is this is a 6-3, like 639 527. I'm trying to find a combination because it can't go down here, so it has to be this way. But if it goes down that way, yeah, it has to go this way. Like the arrow has to go this way because it can't go up here and it can't go down there. So like these 5 digits have to be different, and the only combination I can see work is if this is a 6-3, which would be a 2-5-7. 9. I don't know if I did that in the right logic though. Like I feel like there should have been like a something simpler, like, because I can't have, since I know that it goes this way, I can't have a 5-4 pair, because then this would be a 2, and I can't have like a 3 plus 2, like it doesn't equal this, right? So do I take the chance and just do it? Like again, I thought this was a 7. I thought this was a 2. I thought this was a 5. I thought this was a 6. And I thought this was a 4. And oh no, not a 4. A 3. Because you can't get 10 right there, Michael. And a 9. I said it right the first time. But God. See, I feel I'm so angry at myself. Because like I missed like, I got like rid of like a whole bunch of lives right there. Oh my God. This is an 8. Three. Okay. God, I feel like I did that in the dumbest way. We need just one more digit in here. What does it make these? There's an 8, 7, 5. And then here would be a 1, 2, 3, 4, 9, and 8. Which we know this can't be a 9. Um, 4 plus 1, 5. This could be either or. Oh, this 4 sees this. So this is a 4. Oh, this is that. This is the 7. So this is a 2. This is a 3. So if this 3 sees that, this 2 sees that. Okay. Oh, this 5 sees this, so this is a 4, this is a 4, this is a 5. We know the 4s are down here. 5s are right here. 5s are down here. Oh, I know the digits here. So this is a 7, 8, 9, 8, 9. That's a 4 up here. Nothing right there. 7, 7. So the 4 is not here, so we know that there's a 4 here. So if there was a 4 here, this would be 3. Doesn't really help, so okay. Oh, what digit's that? 38? 2, 3, 4. We at least know this. Because at 38, it's going to be like massive. So 1, 2, 3, 4, 5, 6, 7. 8, 9. It could have these. But it's not 9 because we have the 3 and the, like we have 38, so that's a minus 45 is 7. So either there's 1 digit missing or 2. Oh wait, there's 1 digit right here. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So it has to be a 7 not in here. So we know the digits that have to be in here. So that means we know that this is a 1. Oh! I hate myself right now. Am I looking at this all entirely wrong? That is a 38, right? I can't see under this 8. Like if I delete that, yeah, it goes away. It goes away, so I can't really see it. 1, 2, 3, 4, 5, 6, 7, 8. I'm so confused. That means it has to have a 7 missing. Why didn't it say that there could be a 1? Could there be a 1 somewhere? 1, 2, 3, 4, 6. Maybe it's like this. Can I get 6 digits? Like, so can I have like 3 digits outside of this? That makes a 7. What makes a 7? 1, 2, 4. Holy cow, that can actually work. I was thinking that this was too small to not to be connected with this, but it can actually reach this. And we know that this extends up, so we know at least that, my God, this actually works. So we know that there's not a 1 here, because there has to be that, like, 3 digits outside of it. So this is not a 1. So this is the 1. Holy cow. We don't have a cage number right here. What in the world? I'm so confused. We should have a cage number right there. What? Oh my God. I don't know, guys. So this has to equal 30. Only way to do that is 3, 5. Right? So 8. I think that's it. 'Cause let me see. I'll do it the other way. 16, 22 plus 8. That's 30. So 38. So that means these digits are 2. Oh, wait. I had 8 in there in accident. So this is an 8. So this digit is these 2 digits are 2 and 4. So no 2, 4 here. No 4. It's not going to be a 4 here. Since we know that there's a 4 here somewhere, this is going to be a 4. This is a 2, this is a 4, this is a 1, this is a 2. Just getting rid of some bookmarks here. Okay. Oh no, I was gonna put the 8s right here. It's not right there. Hold on one second. Alright, so kind of just getting rid of some of these. Oh, we found one. I actually just noticed this 5 is outside of here. So this is going to be the 7. Okay, that's a 3, 5, 6. Oof. Oh, I meant 4. My bad. Oh. Oh, why? I took it off the bookmark here for some reason. My bad. I have no idea why I took that off. Okay. Oh, I can see this now. Duh. Does that do anything? I don't know. Oh, but I do see this. Oh, so this 6, 7 sees each other. So this is a 2. That might be it right there. Just trying to be careful because of the, like, I literally have 1 life and I'm done for. Oh, yeah, this 4. So these 2 5s. It's weird that this cage didn't have a clue. It was literally just there to trick us about this one. Like, that was literally what it was there for. It's so messed up. Oh, the 6 sees this. So the 6s are not here. 6s have to be here somewhere. This right here is a quadruple 6, 7, 8, 9 pair. So this is actually a 35. I don't know if these matter anymore, so I'm just going to get rid of the... Oh, that didn't make it easier on the eyes at all. I thought that was going to make it easier. Trying to think of this this addition right here. 6. Oh, this 2. I broke that one. My bad. So this is a 6-9 pair, which this 9 sees that. So this is a 9. This is a 6. Well, there we go. That last one that I didn't see is gonna resolve this whole thing. Because that is a 3. Get rid of that 6. 3, 7, 8. This is not a 3. Since the 6 sees this, the 6 sees this, and there has to be a 6 here. So looking at the last portion of this, it actually looks like we're going to have to use that logic of this right here to see if it flows around. So I'm just going to pretend this is a this color is an 8. So if this is an 8, that means that's an 8, which makes that an 8. And then either of these can be 8s, but 9 will also be spun around. Make that a 8, that a 8. I guess let's make that the 7. Oops, I did the wrong color here. I mean, that works. Oh wait, what am I doing here? This number is wrong. So if this was a 9, this would be a 7. 7, 3, 7. Would this always be a 7? Let's check that again. So if this is an 8, that makes this an 8. So that makes that a 7. If this was a 7, this would make this a 7. So this would be a 7. So this is always a 7. I was hoping that it was gonna like stop the puzzle right there, but apparently it didn't. Okay, so if this is a 9. 9 goes right here, 9 goes right here. 9, 9. Which makes the 8 go. What am I missing? We only have like one more digit basically. Why is this so hard? So if this is 9, this has to be 9, which makes that 9. I'm just gonna do this as a, that does check out. The 6s don't care. So yeah, that works out just fine. I thought I checked the 8 worked just fine. Let me see, if this is an 8, that's an 8, that's an 8, which makes this the 8, this the 9. Oh. Oh wait, never mind. Okay, so if this is a 9, this was an 8, right? In this scenario? Yeah. This is an 8, this has to be a 6. Should make that the 6. 9, 9. This had to be a 7. 7. 3. 3. 7. This checks out every single way. Oh, digits can't repeat in a cell. That's the reason why they had this cage here without a number, and it was just to tell us that it can't repeat. There we go. Alright, well, now we're done. Oh my god. That was an interesting one. So yeah, I'm curious to see like how you guys like this. Like it was really interesting the way, again, it reminded me of Advanced Wars, or like what do you call it? I have to stop for a second and think. What is the Fire Emblem? There it is. It reminds me of like the way that the fog works in that game, and so super unique. I think this was cool just because like it was interesting because you had to like solve this portion in order to get to the next part. It was almost like a video game. So I don't know, whoever made this, that was insanely good. Anyways, I will talk to you guys later. Thank you guys so much. Have a good one.